concentricity. Think of it like dropping a pebble into a perfectly flat pond. You get the center point of impact where the pebble goes in, and then ripples radiate out from that central point, giving us rings all concentric to the center point. When we're talking about concentricity, we are talking about referencing this central axis of any round bar that we might be machining, and making sure that the center point of this ring is exactly the same as the center of this ring, is exactly the same as the center of this ring, etc, etc, etc. You can keep going on and on and on. Concentricity is ever decreasing or ever increasing circles, but they must all be centered around exactly the same point to be considered concentric. Even the symbol for concentricity is, as you can see, circles based around a shared central point. So no discussion on concentricity could be completed without mentioning our friend the 3-jaw chuck. Wow, where would we be without it? It makes life so easy. We can get a piece of material, we can throw it in, it self-centers, and we can start machining straight away. Well, let's do that. I've got a piece of brass bar here. It's going to get a bit noisy. We'll spin her up. I'm not going to take any measurements, it doesn't really matter. We're just going to take a cut. You might pick out there's a little bit of wobble. So that's a fresh piece of bar stock, straight from the factory. They're not machined truly round before they come out. So we initially need to eliminate that as quickly as possible. So we're just going to touch on, and then I'll feed in a little bit. For those of you with metric sensibilities, my apologies, my machine is in thousandths of an inch rather than in any kind of metric measurement. So I've just taken a quick 5 thou cut off of there, which is just a cleaning cut. And we'll just let that run through. And then hopefully that should be enough. We've cleaned the material, not the best finishing in the world. A little bit burred, but yep, that's clean. Now we can measure it. So I've wound my DTI across. I keep a little stand actually mounted to the carriage of the lathe, just makes life a little bit easier. It's roughly zeroed. We'll just give it a turn. Doesn't really matter, we're looking for needle movement, and as you can see, I've got nothing. Excellent. So to the new center line that we've set up by machining this shoulder here, it's perfectly concentric. And if I were to machine another shoulder further in, so we've got a step, that should remain concentric. And I could machine as many shoulders, make as many changes as I want to this piece of material, and they should all revolve around the center line which I've just set up. Now let's just move that out of the way, and we're going to do something really simple. We're going to take it out of the chuck, we're going to move it about a bit, we're going to put it back in again. So undo the chuck, and we're just going to take the material out. I'm not going to do anything else to it. It's out. And make sure it's still clean. I'm just going to randomly, without paying any real significant attention, see I can spin that wherever I want, put it back in the chuck. Nip it up, same amount of tightness as I had before. I'll bring my DTI back in. Put it back in the middle. Not far off zero. Not going to attempt to zero it, it's needle movement we're looking for. And well, as we can see, that simple act of taking it out of the chuck, putting it back in the chuck, we've got 5, 6, 7, 8 thousandths of an inch difference to its concentricity. So that now, if we needed to make another concentric feature based on this one, we would have a real difficult time. In fact, the only real solution to it now would be to take it out of the 3-jaw chuck, put it in a 4-jaw chuck, and then clock the 4-jaw chuck in to this face here, and then we could carry on machining once we've got that concentricity back. But as you see, the moment you take anything out of one of these is the moment you lose all your accuracy. This is why the process planning sheets that you should do before you do any kind of machining is so critical, so that you can plan all your operations without having to remove the material from the chuck, or at least as many operations as is physically possible. And only when you've done all of those concentric operations do you even think about taking it out of the chuck. So I've taken the chuck off, and for this we're going to use the ER32 Collet holder. So it's on a Morse taper. It fits into the output from my lathe. Just take the chuck off, put it in, and put a drawbar at the back. Why? Because we're looking at concentricity, and as we've seen, concentricity and the 3-jaw chuck don't go hand in hand at all. So this gives us the most degree of accuracy and the most degree of repeatability. Lots of different collet chucks are available, and this basically just has a little tapered collet with slots in, and that goes into this tapered hole in the collet holder, and then as we do this nut down, it compresses this, which squeezes the little individual tapered fingers down onto whatever piece of material we're trying to hold. Generally I tend to use them for holding milling cutters, because again they have a high degree of accuracy, so you can swap and change milling cutters very easily. So that will sit in there. Then our material, which in this instance I've turned down to 19mm. That's the largest collet chuck that I've got, 19 to 20. And we'll just nip that up. So what we've done, we've got a piece of aluminium, turned the major diameter to 19mm, and then I've turned an arbitrary amount of material off at each end in order to examine concentricity. One end I've done using the collet chuck, the other end I did using a 3-jaw chuck, and then we can, by using a DTI, measure the difference between the two. Okay, so I've got my DTI set up, set it to 0. We're on the shaft. I can confirm that because if I gently push down on the DTI, we can see the needle deflects. If I gently push up, we can see the needle deflects just by the slight degree of movement I get from the arm that I've got. Now if we rotate the shaft, and we can actually see any lack of concentricity that we may get. And got to say, for an old lathe, that is as near to 0 as makes no odds, certainly for the sort of thing that you'd expect to measure on a reasonably low accuracy DTI like that. That's a really good measurement. I'm 100% happy with that. Now if I'd been using a 3-jaw, I would have expected a lot more inaccuracy. I could improve the accuracy. I could reduce this huge amount of overhang that I've got from the bearing here to where the actual material is. But with this current setup, this is probably the highest degree of accuracy I'm likely to achieve. So that end, perfectly concentric. So swap ends again. Same setup, DTI's been zeroed. This is the end that I machined with the 3-jaw chuck, same piece of material. And now if we rotate it, what we start to see is a huge swing on the needle, which instantly tells us it is not concentric at all. And in fact, if we let's pick the lowest point there, roughly zero that in, we can now measure how far off of the center line this is. Excuse the imperial measurements, but we're about 15th thou off of being concentric. So we can see that this component, because it's been machined not in our nice rigid concentric setup, with the Collet chuck, but we machined it in a 3-jar chuck. We can see that we're miles off of concentricity. And you can also see how easy it is to actually measure the degree of accuracy you're getting with concentricity. Simply introduce a DTI into the setup and you can make an easy comparison between what is your baseline of 0 and what you're actually recording. In theory, any component, as long as you don't take it out of any chuck, will be concentric to any other part that you've machined until you've taken it out. So you should always expect, to be near around the 0 mark on your DTI. The moment you start to see movement like we're experiencing, then at some point you've lost your concentricity, and it's almost definitely because at some point you took it out of the chuck.